Welcome all. In this lecture, we are discussing about power diodes. So let us have a quick review of signal diode. So we know that a diode is made up of an N-type and P-type semiconductor materials. So let's discuss how an N-type semiconductor is formed. So N-type semiconductor is formed from a pure semiconductor material such as silicon or germanium. We know that the pure semiconductors like silicon or germanium are having 4 valence electrons. Means they are having 4 number of electrons in the outermost shell, like this. And we can form a N-type semiconductor from this pure semiconductor by adding some impurity to this pure semiconductor. In order to form N-type semiconductor, we have to add pentavalent elements as impurity to this semiconductor, such as arsenic or phosphorus. Pentavalent means it is having 5 valence electrons, like this. Consider arsenic, this is having 5 valence electrons. So if you are adding this impurity to this silicon semiconductor, pure semiconductor, it will form like this. Means each 4 electrons will combine with 4 electron of this arsenic and form a covalent bond. Okay, so there is an excess of electron. 4 of this silicon will combine with 4 of this. So there is excess of 1 electron, means a negative charge. Okay, so this negative charge will improve the conduction of N-type semiconductor than the pure semiconductor. Okay, so this forms a N-type semiconductor and it is having number of such negative charges. Number of excess electrons are there, so number of negative charges are there in the N-type semiconductor, and because of this negative charge there is conduction. Okay, it is called negative charge carriers. So in N-type there are negative charge carriers. Similarly, we can discuss how P-type semiconductor is formed. So we can form the P-type semiconductor from pure silicon by adding trivalent impurities. Means it is having 3 valence electrons such as boron or gallium. So boron is having 3 valence electrons. So again, if you are adding these type of elements to this pure semiconductor, it will form P-type semiconductor as. So if you are adding this, this 3 will combine with this 3, and in order to form the covalent bond, there should be a need of additional electron. There is an absence of an electron. In order to form the covalent bond, there is an absence of electron, and it will create a deficiency of electron is there, and this will create a deficiency of a negative charge, or absence of negative charge means it is a positive charge. Okay, presence of positive are called hole. So it is a absence of a negative charge or absence of an electron. So it is a positive charge called hole. Okay, so this form P-type semiconductor, and the P-type semiconductor is having number of holes or number of positive charges, and this positive charges is the reason for the conduction of in P-type semiconductor. So this is how P-type and N-type semiconductors are formed, and now let us discuss how a diode is formed. A diode is actually a combination of this one P and one N-type semiconductor. So we know that in N-type there is number of negative charges, and P-type there is number of positive charges. In order to form the diode, we are combining these two. Okay, we are forming a PN junction. Okay, we are combining these two. So we know that there are number of positive charges in here and number of negative charges here. So since there are positive here, negative here, this will diffusion will take place. Means the positive charges from here will diffuse to this N, and negative charges from N will diffuse to this region. When positive charge is diffused from P, there will be a negative charge in here, and when negative charge is diffused from N, there will be a positive charge here. Okay. So by diffusion, there will be a positive potential here and negative potential here, and will create a potential. It is called barrier potential. Okay. So there is a barrier potential formed by this combination, by the diffusion of these charges. Okay. And this will, once the barrier potential is formed, it will actually say barrier, and there will not be any further diffusion. Okay, there will not be any further flow of charges. Okay, and this region is called diffusion region or space charge region. Okay, and this is depending upon the doping. Okay, so if it is lightly doped means the impurity addition is less, this region will be very large. Okay, and if it is heavily doped, this region will be very less. Okay, and there is having two terminals for a PN junction. This is called anode and this is called cathode. Okay, and this is the symbol of a diode, anode and cathode. And let us now go to the working of a diode. So if we are connecting the anode terminal to the negative voltage and cathode terminal to the positive, this will be creating a negative potential, and this will assist to the barrier potential, and it will increase the space charge region. Okay, barrier potential is actually increased here. The effect will be an increase of barrier potential. This connection is called reverse bias. Okay, here anode is connected to negative and cathode is connected to positive. Okay, so since the diffusion region or since the space charge region is becoming increased, the no charge flow will happen. Means there is no current flow under this condition. Okay, but there will be a small reverse saturation current, a small current called reverse saturation current, because of the minority charge carriers present in both P and N regions. But in fact, we can, if we are neglecting this will be very small. If we are neglecting this, we can say that there is no current flow or like that. Okay, so that is the reverse bias. And if you are increasing this voltage, it will cause a breakdown and it will damage the device diode by flowing a high current. Okay, so we cannot operate under this region because it is a damage of the diode. Okay, and again, suppose we are connecting positive to anode and negative to cathode, it is called forward bias. Okay, and here it is positive, so this negative charges will attract to this positive and it will disappear. Similarly, this positive charge will attract to this negative and it will also disappear, and this will make the diffusion region thinner. Okay, and the potential is barrier potential is now reduced, the wall is now reduced, the space charge region is now reduced, and in forward bias condition the diode will conduct. Okay, so it will conduct like this. Okay, a large current can flow. Okay, a large current can flow. So this is the operation of a diode. Now we can discuss how a diode can be acted as a switch. Okay, so if you are operating in this region, we told that we cannot operate beyond this limit. If you are considering here in reverse bias condition, there is only a small current. Okay, only a small current means when VAK is negative, means it is negative, P is negative and N, anode is negative and cathode is positive, means VAK is negative. Under this condition, there is no current flow, means it's an open circuit. It is equivalent to a open switch. Okay, so in reverse bias it is open switch. And if you are considering the this forward bias region, when VAK is positive, it is large current is flowing. Okay, large current is flowing, means it is a closed circuit, means it is a equivalent to a closed switch. So when VAK is positive, it is a closed switch, and when VAK is negative, it is a open switch. Means diode is acting as a switch. Okay. So this characteristics of diode we are using as in power circuit. Okay, for switch. So for using the diode in power circuit, we need large current flow. So when the switch is closed, the current should be very high. So it should be capable of carrying a high current, and when switch is open, this voltage should be very high. Means this barrier voltage, this is actually the barrier voltage. The voltage that has to be withstand by the switch is actually the barrier voltage. Okay, above barrier voltage, this device will be damaged, so we cannot use as a switch. Okay, so while using the power circuit, this V and I should be very high. Okay, so in order to increase I, it is very easy. We can increase the cross section of the device, and we can increase the current carrying capability. And in order to increase the V, what we are doing is we are adding an additional N minus. In case of power diode, we are adding a additional layer. This is actually a PN junction, but we are adding a N minus. N minus means it is lightly doped. We told that in order to increase the space charge region, in order to increase the barrier potential, we need to dope the region lightly. Okay, if it is lightly doped, the region will be very large, and if it is highly doped, the space charge region will be very thin. Okay, so in order to increase the barrier potential, we have to increase the diffusion region, space charge region. So we are giving a additional N minus. Now if you are connecting reverse bias, the space charge region will be this much. Okay, in P region it is highly doped, so it is very small space charge region, but the N is lightly doped. N minus represent it is lightly doped, so it is having a high diffusion region. Okay, thus we can increase the barrier potential. Okay, so while the switch is in off condition, the diode can withstand this much voltage. Okay, and increase of cross section, we are increasing this cross section in order to increase the current capability. So these two are the additional constructional feature in a power diode to increase the power capability. This for voltage capability, and the increase of cross section for current capability. Okay, again we told that we can use the diode as a switch, and again we discussed we can increase the power capability by increasing the current capability and voltage capability. So we know that when VAK is positive, the diode will turn on and start conduction. Okay, it is in turn on position when VAK is positive under this condition. Okay, forward bias condition, and once the diode start conduction, it will turn off when the anode current reduces to 0. Okay, so these are when it will conduct. When VAK is positive, diode will conduct, and diode will turn off when the current reduces to 0. Okay, so means it is conducting, this turning on when VAK is positive, and it is turning off when current is 0. So there is no control over the switch. Okay, we cannot control. Okay, whenever VAK is positive, it is start conduction, and it will reduce to when it will turn off when the current reduces to 0. Okay, so it is called a uncontrolled switch. So that is the disadvantage of a diode, power diode. We cannot control the turn on or turn off. Okay, so in order to overcome this disadvantage, thyristor is evolved. A device called thyristor is evolved. So we can discuss the thyristor in next session. With this, we are winding up this session. Thank you.